Here we have a do-it-yourself problem where you're asked to find dy dx when 2x to the fifth plus xy squared is equal to minus 4y cubed plus 7x. So we're going to pause the video, give you a chance to do implicit differentiation. Remember that when you differentiate y's, you treat them differently from when you differentiate x's. When you differentiate y's, you must use the chain rule and tack on a dy dx because y is an implicit function of x. Now let's go ahead and take the derivative with respect to x of both sides of the equation and see what we get. We get 10x to the fourth, that's just a function of x. But here when we differentiate xy squared, we must use the product rule. So let's leave y squared alone and differentiate the x. We get 1. So we get y squared. Now let's leave the x alone and differentiate the y and get 2y. So we get 2xy, but then of course we get dy dx. And on the right hand side we get minus 12y squared, and again a dy dx, but here when we differentiate 7x we just get 7. Now we have to go ahead and solve for dy dx, putting all the terms involving dy dx on the left side of the equation and everything else on the right side. We'll pause again to give you a chance to do that. Here we have the terms involving dy dx circled, so we're going to go ahead and put those on the left side of the equation, everything else on the right side of the equation, and we get 2xy dy dx. When we put this term on the left, we get plus 12y squared dy dx is equal to 7 minus 10x to the fourth minus y squared. And now we have to factor out the dy dx. We'll stop once again and give you a chance to finish the problem. Okay, let's finish this by factoring out the dy dx. So we get 2xy plus 12y squared, all of that times dy dx, that's a common factor, is equal to 7 minus 10x to the fourth minus y squared. And now all that's left is to divide both sides by dy dx, and we get, we'll put it in a new color, dy dx is equal to 7 minus 10x minus y squared over 2xy plus 12y squared, and that is the answer to our problem.